Good morning. Excuse my appearance this morning. I did an early workout. But nonetheless, I am here for you to review for your test. So let me grab everything we need. I hope that some of you watched the review from yesterday. I know at least Garrett did because he commented on Kevin interrupting my class. But anyway, we are just going to move right along. I'm actually trying to remember where we ended yesterday. Let's see. I know I had 4 left. Okay. So that means we finished on practice problem number 9. So we are going to go ahead and move on. Let me grab my test. Good morning, Kason.
Hello.
You gonna bring us some music today? Watch the first part of the review yesterday.
Not yet.
Okay, that's fine. I'm just
I
gonna
had to work all day.
You've been busy at Publix.
Yes.
Do y'all have toilet paper?
No.
All right, well, I'm going to start with a question that is actually on the test. It's a 12-point question, so this is one that everyone will want to pay attention to. I'm going to write it out. Okay. Bright light that comes from a flash bulb is due to a quick combustion of magnesium. According to the following chemical equation. So that 2 should be a subscript, but I'm just going to leave it a 2 because I don't really know how to do that on here. And the equals is basically the arrow. It's the best I can do with the weird way I have to type in here. Sorry for that. Okay. If a flash bulb contains 1.3 grams of magnesium, what is the minimum pressure of O2 needed to burn up that magnesium? In the flash bulb has a volume. The reason I'm taking this straight from your test is because I always look at your test and try to pick all of the review questions that are similar, and there was no question similar to this in the review. So I thought it'd be better just to go ahead and do it this way so that you can get a good idea of what you should do. I really understand it. Okay, so this is your question, and yesterday I talked a little bit about just really reading the questions and picking them apart, listing all the pieces of information that you're given, and looking at what they're asking you for, and then looking at your equations. Let me pull out the page for you. It's at the end of your module. It's on page 410, and it has all the equations listed there. And once you pull apart all the pieces of information you're given and figure out what they're asking you for, you can look there and just kind of pick out what equation would apply. So first, let's see what we have. We have a chemical equation, which normally tells me we're going to use stoichiometry in some way. So then I'm going to see what else they give me. They give me 1.3 grams of magnesium, and they ask for the minimum pressure of O2 needed to burn it up. So they're going from one substance, magnesium, and they're asking me for an amount of another substance, O2. So that's where stoichiometry is going to come into play. And then it also gives me a volume and a temperature. So that's going to help me figure out what I need to know. So if we're going to use stoichiometry first, we always need what unit?
Grams, moles.
Moles, yes. So we're going to go from grams to moles. That's what I'm going to do first. Let me just make sure that is what they do. Yep, that's what they do. Okay, so we're going to start with our given value of grams, which is 1.3 grams of magnesium. And we're going to put that over 1. That's our given value. I'm going to multiply it by a conversion factor. And I'm going to moles. So 1 mole is going to go on top. And then I'm just going to look at the periodic table to figure out how many grams are in 1 mole of magnesium. It's going to be 24.3. So 24.3 grams of magnesium are in 1 mole. This is my conversion factor. Once you put that in your calculator, let me move our little camera so I can see. Once you put that in your calculator, you will get 0.053 moles of magnesium. Okay, so now we have moles of magnesium. Now we're gonna want moles of oxygen, right? Of O2. So we're gonna use our chemical equation and stoichiometry to go from moles of magnesium to moles of oxygen. So let's start with our given, which is this value we just figured out. So 0.053 moles of magnesium. It's going to go over 1. We're going to multiply it by a conversion factor. And on the top of my conversion factor, I'm going to moles of oxygen. So I'm going to look here. In the chemical equation, I have 1 mole of oxygen. And for my other, on the bottom, for moles of magnesium to cancel, I'm going to look here, and I have 2 moles of magnesium. Okay, so you're going to put that in your calculator. Your 1s really essentially cancel out, so you don't need to worry about those. So in your calculator, you're just putting 0.053 divided by 2, because 2 is in the denominator. Once you do that, you're going to get 0.027 moles of O2. Okay, so I have moles of O2. Now I have volume and temperature of O2. They're asking me for pressure. So if I look at that page that has all the equations, I'll notice that the ideal gas law is going to be the equation I'm going to want to use. Whoop, let me type. PV equals nRT to plug it in and figure out and solve for the pressure. So first I'm going to go ahead and make my equation solved for pressure so I can just plug it in. So I'm going to divide by volume, and volume will cancel. And I'm going to divide by volume on this side. So the equation I'm using is pressure equals number of moles times the R constant times temperature divided by volume. So we're just going to plug it in now. We have everything else that we need. So the number of moles is here. We just figured it out because we're solving for pressure for oxygen. So number of moles is going to be 0.027 moles. And my R constant you memorized, or you should be memorizing, is 0.0821. And the important part here is the unit. So it's liters times atmospheres divided by moles times Kelvin. I'm going to have to rearrange this. Let me, I'm going to move this so that you can see it better. So it's all in one line. Okay. How do I paste? There we go. Okay. All right, close parentheses. And the next value on the top is going to be temperature. I'm just going to do another box so it will show up right. Okay, but the temperature I need, remember, always in Kelvin to match up with our units. So I'm going to go from 25 degrees Celsius to Kelvin. So over here, I'll convert 25 degrees Celsius plus 273.15, and you'll get 298.15 Kelvin. Just going to plug it in my equation now that I have the right number, 298.15 Kelvin. Okay. And all that's together on the numerator, divided by the volume. And they give it to me in milliliters, but you'll notice for your R constant, the unit here is liters, so I am gonna have to convert that one as well. So I'm gonna go 10 milliliters to liters. So we can do it with a conversion factor if you so desire, or you can do it in your head, as I'm sure you will. So let's go 10 milliliters over 1 times 1 liter on top, because that's what we're going to. And then we want milliliters to cancel, so that's going on the bottom, 1,000 milliliters. Once you put that in the calculator, you're gonna get 0.01. I'm gonna put that on the bottom here. 0.01 liters. Okay, and then you're just gonna plug this on your calculator. So in the calculator, it's going to look just like this on the top with everything. So you'll do, here, I'll type it out for those of you who are struggling with how to plug things in the calculator. Open your parentheses, 0.027 times 0.0821 times 298.15. Close your parentheses. That whole thing divided by 0.01. Plug it in the calculator, and when you do, you're going to get 66. I'm gonna plug it in just to see. That's probably their rounded answers. Let me check. Whoop. Bear with me. Okay, I got 66.09, but in your question they give you, they are using 2 significant figures, so I guess they're wanting you to round. So you're gonna round down to 2 significant figures. That's where the 66 came from. And the unit is atmospheres, because if you go back here, you'll notice moles is here on the top, here on the bottom, Kelvin on the top, Kelvin on the bottom, liters on the top, liters on the bottom, and the unit I'm left with is atmospheres. So this is your pressure. That's your answer. And this again is a 12-point question on your test. But I just showed you how to do it. So if you don't understand any of those steps, just let me know. But again, just those of you who are watching later too, just slow down when you're given a word problem, read it, list out all the information you have, and try to figure out what they're asking and pick out your equation from there. So the reason I knew stoichiometry, first of all, was I saw a chemical equation. That's always like a red flag. Next question we're gonna do is going to be in your extra practice problems, and that's on page 283 in the student book. All right. We are gonna do number 1. This is a 4-point test question, one similar to it. I'm gonna go ahead and clear this out. All right. Oh, sorry, I'm trying to rearrange my screen here. Okay, so it says a balloon is filled with air so that its volume is 11.2 liters at 25.0 degrees Celsius. It is then lowered into the vat of liquid nitrogen so that it reaches a temperature of negative 196 degrees Celsius. Assuming that the pressure stays constant, what is the new volume? Okay, so let's just think about what we're given here. I'm gonna kind of type it out because this is what happens in my head. I'm given a volume, 11.2 liters, that's a volume, okay? I'm given a temperature, 25.0 degrees Celsius. I'm given a second temperature, negative 196.0 degrees Celsius, new temp. Okay, and they're saying the pressure is constant, and they're asking for new volume. Okay, so when I see that, I'm seeing a volume, a temperature, a new temperature, and asking for a new volume. So in my head, it's ringing a bell that I'm going to be using Charles's law. I couldn't remember if it was Charles or Boyle's, but I'm going to use Charles's law because that's the one that uses temperature and volume, because it tells me the pressure is constant, so I don't need to worry about pressure. If we were involving pressure, it would be the combined gas law. Okay, so Charles's law says P1 over V1 equals, I'm sorry, this format is like crazy. I don't know if it's gonna let me write it. Okay, let's fix that. Oops, I didn't mean to do that. Okay, just ignore this. All right, P1 over V1, so that's my first pressure, my first volume. Nope, I'm doing that wrong, sorry. I'm all messing up today. All right. What is going on here? All right. I'm going to get it together, I promise. All right, P1 V1 equals P2 V2. Need to refresh my memory. Okay, P1 V1 equals P2 V2. So this is your original pressure, original volume, new pressure, new volume. We're solving for new volume. So I'm going to go ahead and solve this equation so that I can get it by itself. So I'm going to divide this side by the new pressure. That cancels. Divide this side by the new pressure. So your new volume is equal to pressure times volume divided by new pressure. So now I'm just going to plug it in. So in my equation, I have the initial pressure. What am I doing? I'm sorry, I'm doing volume and temperature. Y'all just, I'm going to erase this whole thing. I'm going to start over. I don't know what is going on with me. Okay. We're going to start over. So we have volume and temperature. We're going to use Charles's law, which is volume over temperature. The last 3 minutes, just pretend you never heard that, because I'm losing my mind. It's too early today. All right, V1 over T1 equals V2 over T2. All right, now I'm going to solve for volume. So I'm going to multiply this side by the new temperature. And I'm going to multiply this side by the new temperature. Do the same thing to both sides. It's going to cancel over here, and then new volume is by itself. So new volume is equal to original volume times new temperature divided by original temperature. Now we can plug it in. Again, the last 3 minutes, ignore. Okay, volume 1 was 11.2 liters. Okay. And the new temperature is given to us in Celsius, and as we know, we need to convert to Kelvin every time. So first we're going to do that. So we have negative 196.0 degrees Celsius plus 273.15. Like that in a calculator. 77.15 Kelvin. Make sure that's right, because apparently I'm crazy today. Yes. So this is going to be the new temperature. The new temperature. Okay, so you're going to multiply this volume times this temperature. It doesn't help that I have to do it in this weird looking way. This is together. I just didn't get it all together there. Over our original temperature, which is also given to us in Celsius, 25 degrees Celsius. We're going to convert that plus 273.15. We're going to get 298.15 Kelvin, and I'm going to plug that in over here. Okay, so plug it in your calculator like this. open parentheses, 11.2 times 77.15, close parentheses, divided by 298.15. When you do that, you're going to get
This is the first equation.
this is the first extra practice problem. Equation-wise, you're asking what equation it is?
Yes.
This is Charles's law, equation 11.5. The V1 over T1 equals V2 over T2. Because pressure is constant, so we don't need the combined gas law.
But that's I was getting confused. I was looking at problem 2 on here.
Oh, well, that could be where you're getting confused. But I was also confused at the beginning. I was using the wrong equation. So I apologize. That's partially my fault. Okay, so our answer, once we plug it all in, they're asking me for the new volume. So unit is liters. So it's going to be 2.90 liters. I got 2.898, but I need to get it down to 3 significant figures. So I'm going to round to 2.90. So your new volume is 2.90 liters. I know that was really confusing, so if anyone's watching later and you don't understand, feel free to reach out. But when pressure is constant, we're just using the equation for volume and temperature, which is Charles's law. I'll type that right here. Okay, and this was practice problem, extra practice problem number 1. Now we are moving on to extra practice problem number 2. Hopefully I won't be reading the wrong thing this time. Okay, this is another 4-point question on your test. A balloon is filled with helium at a temperature of 25 degrees Celsius and a pressure of 755 millimeters of mercury. So that is, volume is 13.3 liters. It then rises to an altitude where the temperature is 15 degrees Celsius and the pressure is 625 millimeters of mercury. What is its volume at that altitude? Okay, so I'm just going to type out the information I'm given as practice for you guys when you're reading a problem, if it will let me. Okay, so I'm given 25 degrees Celsius, which is the temperature. I'm given 755 millimeters of mercury, which we know is a measurement for pressure. I'm given 13.3 liters, which we know is a volume. And then I'm giving 15 degrees Celsius, which is a new temperature. I'm given 625 millimeters of mercury, which is a new pressure. And then they're asking me for a new volume. Okay, so this means I have one set of temperature, pressure, and volume under one set of conditions, and then I have a new temperature and pressure in our second set of conditions. So I'm going to use the combined gas law, which is, let me type that out, combined gas law, which is P1 V1 over T1 is equal to P2 V2 over T2. Now I need to rearrange this for the piece that I'm trying to solve for, which is the new volume. Okay, so if you write it out, this will help you. Okay, so I'm solving for V2. So I need to get it by itself. So what I'm going to do is multiply by T2 divided by P2. I'm multiplying this whole thing by this whole side of the equation, which means T2 will then cancel out and P2 will then cancel out, leaving V2 by itself here. And I have to do the same thing to this side. So I'm going to multiply this side by T2, just like I did here, divided by P2, which means my new equation to solve for the second volume is going to be T2 times P1 times V1 divided by P2 times T1. Now I just need to plug everything in. So first, let's just get everything into the right units. Everything looks good here except for the temperatures. So let's go ahead and convert our temperatures. So this is temperature 1. I'll convert that down here. So 25 degrees Celsius plus 273.15. They use that one a lot, so you should basically have it memorized. 298.15 Kelvin. Okay, now let's convert our second temperature here. So we have 15 degrees Celsius plus 273.15. And that's going to equal 288.15 Kelvin. Okay, so now I have my two temperatures. I'm going to label everything just to help me out. So this is going to be my first temperature that I started with. That's T1. This is my new temperature that it went to, which is T2. This is my first pressure, so this is P1. This is my first volumes, that's V1. And this was my new pressure, so that was P2. Okay, now I have all the pieces I need, and I'm just gonna plug them in, see how everything matches up. P1, V1, T2, P2, T1. So I'm just plugging it in. All right, so let me do that here. T2 is first, and that is 288.15 Kelvin. Next, I have P1, which is 755 millimeters of mercury. Then I have V1, which was 13.3 liters. That's all in my numerator here, T2, P1, V1. Okay, now I'm gonna work on my denominator. This is the T here, P2 times T1. So the new pressure is 625 millimeters of mercury. And then T1 is 298.15 Kelvin. All right. Then we're just plugging it in the calculator. So let me write here what it's going to look like in your calculator. Open your parentheses. 288.15 times 755 times 13.3. Close your parentheses. That's your whole numerator. Whole thing divided by, open a new parentheses. 625 times 98.15. Close your parentheses. You put your whole numerator in parentheses, you put your whole denominator in parentheses. So I'm going to plug it in and make sure I get the right answer. All right, I got 15.527, and the unit is going to be liters because that's what we're working with for volume. But I need to round it because they only give me 3 significant figures is the least amount here. So I'm going to round it to 15.5 liters. Does this make sense?
Yes.
Okay. We only have one more review question and then we're done. All right, so I'm going to clear this out. The next one is going to be a question that's directly from your test. So let me move this out of the way. Okay, let me type that out. So the question is, the vapor pressure of water is 30.0 torr at 29 degrees Celsius. If a reaction at that temperature produces oxygen which is collected over water, total pressure will have to be in the reaction vessel to ensure that the oxygen collected had a partial pressure of 560 torr. All right, let's look at how they do it here. This is a 4-point question on your test. Okay, what I'm seeing here is partial pressures and total pressures. Okay, so we are going to end up using the Dalton's law of partial pressures. I'll write that here. Dalton's law of partial pressures. And that is P total, the total pressure, is equal to the partial pressure of one, the partial pressure of another. Okay? And in this case, it's going to be the total pressure is equal to the pressure of oxygen plus the pressure of the water vapor. Okay? Well, they gave me the, let's see. All right, they gave me the partial pressure of oxygen and water vapor. So what I'm doing is just adding them together to get the total pressure. So P total pressure is equal to 30. This was easy. We're gonna fill in, I'm sorry, that was oxygen. So, that was water, so let me do oxygens first. Oxygen was 567 torr plus the 30.4, which is the water vapor pressure, which means the total pressure had to be 597 torr. Seems too easy, but that's all you have to do. I think the temperature was throwing me off because I'm like, are we supposed to do something with that? You don't. So you're just finding the total pressure based off of the two partial pressures that you're given. And that's it. So if you watched yesterday's video, that will give you a full test review. I covered either questions from the test or exact questions that are similar to the questions on the test. All I had, I will the test in our group chat, if that's okay. Are you able to see stuff in the group chat okay?
Yes.
Okay, I'll send pictures, and if anybody can't see that, I'll also send it in an email and post it on Homeschool Minder, just so there's different ways if one method doesn't work for you. And as always, I'll be here if you have any questions on your test. I'm happy to help. Just let me know. And feel free to use your notes and your book for your test, just not the internet preferably. And yep, just let me know if you need anything else.
Okay.
All right, have a good day and a good weekend. And I'll need a test by Monday morning.
Okay.
Thank you.
And you're gonna share the tests on Homeschool Minder?
Yeah, I'll try to post it because I think you can attach pictures on there on an assignment, so I'll also put it there. But what I'll need you to do is just write your answers on like a piece of paper, and then everybody just send me pictures of that, either an email or a text message is fine, or you can scan it because I know some pictures of the homework was a little blurry. So if you do take a picture, just make sure it's clear.
Okay.
All right, and I'll take those by Monday morning. Thank you.
Thanks.
Bye.
Bye.